Hi, my name is Lou D'Andrea. I work at Wolfram Research, and I'll be talking this year about building maintainable dynamic interfaces in the notebook front end. I'm going to illustrate in this talk many of the lessons that we learned during those initial interfaces, and especially the lessons that I've needed to teach people over and over and over again as we build new things in the Wolfram system. These are definitely relevant for people here that are interested in building their own dynamic interfaces. Pardon me? That's why we're here. Okay, so just by way of trying to make sure the right people are here, this is not an introductory talk. This is not what is dynamic. If you're looking for those talks, I've given them in the past. There's some YouTube links here. There's some documentation links. I'm not going to be offended if you stand up and walk out. There are lots of other nice talks going on right now. But there's lots of good information to get you up and running with dynamic module, et cetera. And Jason Harris is giving a chat about typesetting. I don't really know what that's going to be, but typesetting is also important for the talk that I'm about to give. So at least a smattering of typesetting, a knowledge of the box language would be useful. Okay, so last year I illustrated 4 principles of dynamic interfaces. Can the people in the back row see this okay? Okay. So the principles of programmatic generation, minimal dynamics, maximum encapsulation, evaluation blocking. These are very important. I'd encourage you all to go back and watch that video, look at the notebook. But we're going to be digging into the first one a little bit more today, this principle of programmatic generation and best practices for how to create programs that generate interfaces so that those interfaces can be long-lived, can update over time, you can fix bugs in them even though you've burned stuff into user notebooks, et cetera. And programmatic generated interfaces take one of sort of 2 major categories. There's pre-generated interfaces, which are created once and then burned into a file. Our preferences dialog is like this, our about box, a lot of the notebook-based interfaces are like this. We're not talking about those today. We're talking about the generated on-demand interfaces. Things like manipulate, things like the output of Wolfram Alpha, things like the predictive interface, and things like interval slider and dynamic geographics. And we'll be seeing a lot of reuse of this idea. What idea? Well, so let me start off by trying to convince you that there's something worth talking about here. So most of you know manipulate, built-in top-level code, fine. Well, we have all of the dynamic and layout primitives and control primitives. We have slider and dynamic and column, and we can piece them together to get things that look like manipulate. We can get more clever with localization and with formatting and labeling, and we get something that looks even closer to manipulate. But the reason that you don't want to go this route, this is a great route to go. It's important to build interfaces in the Wolfram language using functions, not just hand editing the interface. But if you just go down this route to its natural conclusion, you will wind up with an output that just is a big mass of boxes. It's a big, so I should have probably shown you guys this output. So here we have the dynamic module corresponds to a dynamic module box, the panel, a panel box, the column goes to a grid box, and so on. All these boxes are literally present in the user's notebook. We can't change our minds about the layout of this thing after we burn these boxes into the user's notebook. So if we went down this route, we would have, well, you see the size of the scroll bar thumb, or do you? Maybe you don't quite. But there are pages and pages of boxes here that we could, if we had gone this route with manipulate and just dumped these boxes into user files, well, that would have worked. It would have worked for version 6. When we got around to version 6.01 and we wanted to fix that bug, that layout bug where some manipulates used the wrong grid option and when you had 47 controls and they were arranged just this way, there'd be no way for us to fix that bug for existing outputs. We could fix it for new outputs, but we couldn't fix it for existing outputs because existing outputs are just a big mass of boxes. I'm still not to the bottom of them. Okay. So this would be a bad thing to burn all these things in. In addition to the obvious file size bloat, We have, once we've made the decision of which boxes to burn in, well, then the user is locked into those boxes. The implementation is locked into those boxes. We can't use new constructs in the front end. If panel box got a new option, we couldn't automatically update older interfaces to take advantage of it. We'd have to regenerate every manipulate in the documentation, every manipulate in the demonstrations project. This would be a huge undertaking. Luckily, we don't do things quite this way. We satisfy the following goals. We only store what's absolutely necessary to display the interface. And that interface decisions about display are made at render time, not at the time that the kernel burns in the boxes into the notebook. The graphic design is responsive to option changes, to platform changes, to environment changes. Those of you who went to Rob Breguet-Schofeld's talk earlier saw Manipulate running on iOS. A lot of those things were only made possible because of the foresight that we had when we were building Manipulate and to enter and to burn into notebooks symbolic boxes rather than literal boxes. It also lets us do some very nice things with compatibility, but in both directions. So taking older notebooks, opening them in newer versions of Mathematica, taking newer notebooks with new constructs, opening them in older versions of Mathematica. And I'll talk about details, what I mean by that in just a minute. Okay, so first of all, I showed you the manipulate boxes that we don't generate. Now I'm going to show you the boxes that we do generate. So it still fills just about a page at this magnification. But notice if you look so here we have a manipulate, the layout, we see a panel, we see some probably grid layout, we see sliders. If you look at the boxes that are actually generated, you won't see a slider box. You don't see a grid box. You don't see a panel box. What do you see? Well, you see a dynamic module box for storing the state of the interface, the things that are needed to recreate the interface state. And then you see a dynamic call to a function that actually creates the interface. A dynamic call to a function that actually creates the interface. Dynamic, of course, is only resolved at render time. So those are the only bits, and there's a little bit of initialization stuff at the end. But all this is dynamic module of some state and the dynamic that actually generates the interface. And we've used this idea over and over. When we introduced interval slider in version 10? I don't remember. This is built on top of locator pane for the interactivity. It uses our graphics language to draw the rounded rect slider background and the highlight background and the thumbs. But if you actually take a look at the boxes that are generated, you don't see locator pane, you don't see graphics box, you just see a very simple call to a dynamic display function. Oops, what have I done? Balance. So again, it's a dynamic call to a function that generates the interface at render time. This is the important, you're noticing a pattern here, right? This is I'm trying to drive this home. We've used this for our freeform input, and this is a case where we've actually changed the display over time. So when we first introduced control equal, some people call it, the freeform input feature that goes off to alpha to find a parse for some natural language piece of text. In version 8, it looked like this double-decker thing, where it would show you both the query on top and the parse that resolved to on the bottom. And we played with this all during the 8 cycle and decided, you know what, we don't really want this double-decker thing. We want a single-decker thing. But the way that this was implemented, we didn't have to go back and regenerate each of these. We just open up this notebook in version 10, in version 9 and version 10, and it looks like this single-decker. How did we do that? Well, I think by now you probably know, it is because the interface doesn't store details about the layout. It stores the state that it requires and a dynamic call to a function that generates the interface. And then this function changed over time. Right, and there's more. Again, I'm not going to open the bonus sections during this talk. Please look at them and ask questions about them afterwards if you want to. So Any permanent state, I mean, we've seen some of this. This is a sum up for some and a jumping off point for the rest. The permanent state is stored in dynamic module, and we're just a dynamic of a function that generates the interface at render time. This is the key concept. There might also be some custom interpretation around your dynamic module. There might be tag boxes, interpretation boxes, template boxes. I'm not going to talk in detail about those. I'm happy to talk with you one-on-one about those if you're interested. And then what about actually details of that utility function, the function that generates the interface? What are the lessons that we've learned to make that utility as flexible and useful and maintainable as possible? And I'm going to be talking about each of these in turn. So especially loading your code, passing by reference, communicating with the outside world, and if we have time, detecting when kernel quits. Okay. Feel free to stop me with questions along the way, and everybody else will groan because they're all hungry, but I'm happy to answer questions, and we can go past dinner if you like. So, storing state. We already saw interval slider doesn't have any state to store. Other than the value of the dynamic variable, of the user's dynamic variable, there's no other state here. There's nothing. It's just a utility function that generates an interface. There's no open or closed state. There's no am I animating or not state. It's just sort of the bare bones. There's no need for additional storage here. Unlike manipulate, where we do have a need for additional storage because manipulate has other features like the ability to hide and show controls, the ability to kick off an animation. What else can manipulate do? It has open close of individual controls. It has bookmarks that can be added or removed or edited. And so manipulate, and it has the ability to attach a joystick controller and move your manipulate around. Each of these things requires a little bit of state stored. And so in this case, we do have a dynamic module here to store that kind of stuff. So when you're building out your interfaces, you need to think carefully about, what is the state that needs to be stored? What is the state that we can't sort of generate automatically the next time around? Okay, so by way of a simple academic example, here is the thing that I've repeated several times already. Here's an example of it, an interface function that creates this construct, a dynamic module of a dynamic of something that displays an interface. And here's the interface function. For this case, it's just a dynamic of a local variable, dynamic of a global variable, and some appropriate controls, and then a display of those control values. So let's evaluate this and see that it doesn't, in fact, work. And it's not supposed to work, but it's instructive to understand why it doesn't work. And unfortunately, I've already given you the answer to this in the next subheading title. Otherwise, I would ask you why this doesn't work. This dynamic is calling display of A and var. At this point, A has a value, 0. Var, it looks like var already had a value also, about a half. And so display of A var is getting called as display of 0, 0.5. These variables are passing through their values. And by that point, you can't attach a dynamic slider to a number. You can't attach a dynamic slider to a number. You can attach to a variable, and if you pass the variables through by reference, if you use holding attributes, it will work the way you expect. So this is a key technique when building out interfaces in this way. Whenever you're passing dynamic module variables through from one utility to the other, and you need to be able to change them at one side, you need to make sure that you pass them through by reference all the way down. So here's an example, refactored, that does work, and the only difference is that I've given the display function a holding attribute. Yep. And here we have now that this actually does something. Something boring, but something. Without changing the call here. Oftentimes when I'm building out these interfaces, I prefer to change this call. I prefer to not have holding attributes on the utility function and instead use the holding attributes built into dynamic and a syntax similar to what slider or checkbox or our other control language primitives use. So Same kind of thing here, except instead of relying on holding attributes on the display function, I'm passing these things through as held just by virtue of wrapping them in dynamic. Yeah. So 6 of one, half a dozen of another. I mean, pick a convention and stick with it, whatever you're more comfortable with. But hold those variables as you're passing them around. Okay. So that's one aspect of the technique that's important to understand. Another is how to deal with compatibility issues and making sure that your older interfaces and your newer interfaces play well with one another. Say you have a single function, and you're really proud of this function. So here's I think I use the same, yeah, it's the same structure, just panel of a couple of sliders and a dynamic variable. And really happy with this, send it to all my users. They evaluate it all over the place and have lots of notebooks full of this stuff. But then you have an idea, well, you know what, this list of things, I really would, I just learned this new function, grid, column, maybe I can lay these things out more nicely. Do I need to tell my users to go reevaluate all those things once I update my code base? Well, no, I can just change this, so we have this dynamic utility that's generating the interface, just change its definition. And as I change the definition, you see the existing output was updated. So this happens to be all in the same session, but this could just as easily have been you shipping code out to some user. And it updates because that's what dynamic does. Yeah. Notice also that I've added an argument to this utility function. This argument, this is my convention. Other people might have other conventions. I like to think of it as a versioning argument of this utility. It's not corresponding to the Mathematica version number. It's a version number of the utility. So version 1 of this utility did one thing. I can support all of version 1's features here, so I don't need to bump the internal version number of this utility. But if I have something fundamentally new, for instance, that would cause me to need new dynamic variables being passed through, I can bump that utility number and create a new version of the utility and have newer versions of my package generate the newer outputs. So here we have, I've updated this utility, one down value of this utility, which doesn't affect those outputs, but here we have this new guy that has a slider 2D, just because it looks different. So in this way, we can continue supporting the older outputs and indefinitely, while still developing and building out new things. And Manipulate has used this over the years. What about the other direction? What if I've distributed my package, users have version 1 of the package, they have version 1 of the interface utility. I've created something new. I haven't sent them the new package yet, but I'm starting to send them new notebooks of mine with these new outputs. Well, that would be a problem if the utility that they have had no idea about this new version, the new utility version, which it won't. But you can, in that first version of the package, you can say, if you don't recognize the calling signature for this utility, you have a fall-through case. Say, I don't recognize this structure. So here, if there's an output that calls a version of the utility for which I don't have a definition yet, it can just display something that says, well, you need to contact me to get the newer version of this. Has anybody ever actually seen something like this in product with Manipulate or interval slider or anything like that? Because it is in product, and we've used this for Manipulate for a while. But I guess that means that people upgrade regularly, and that's a good thing. So for instance, if you look, I'm going to open up the boxes here and notice that this Manipulate is a version 3 of the boxes. I don't know if you can see that, because interval slider was added as a control type to Manipulate at some point. And so earlier versions, so if we had changed this to, 30, we're not up to 30 yet, but this is what you would see if you got a Manipulate output from version 47 of Mathematica, of Wolfram system, or whatever we're calling it in the future, and tried to open it in version 11, this is what you'd see. And likewise, if interval slider got some new option setting and the new boxes for interval slider couldn't be rendered in version 11, this is what you'd see. So even though I don't know what next year's boxes are going to be, I can prevent this year's front end, this year's package, from just displaying a big mass of pink boxes or a big mass of internal code splorting all over your screen, which I think is a really nice, is a much preferable experience. Okay, so that's forward and backward compatibility. I think that's kind of nice. We have layout details changing over time. We have the ability for the boxes to look different on different platforms, on different user preferences. There's even some code in Manipulate that changes the layout of your default controls based on the handedness system option that your operating system might have. And I think that's only supported on Windows. I think handedness is only a thing in the Windows operating system, in Windows 10 maybe. But the ability is there, and given that it's a dynamic interface generated at runtime, at render time, this all just works. And as long as you use dynamic, it's just going to work. What are some other things that aren't just going to work? Well, one thing that we don't need to worry about too much for built-in functions, but that you might need to worry about for your interface functions, is making sure that your code is loaded before rendering the interface. How might you deal with the kinds of situations that you encounter around that? Well, an obvious start is to just have a dynamic. Remember, your interface is a dynamic function that runs at render time. So that interface function can check to see whether your code is loaded. It can do some value queue or down value arrow, down value same queue of empty list or something. In this case, I just have, does this symbol have a value? And is the value true? Evaluate this. If it hasn't been loaded yet, let's see. If this is true, then this displays ready, and if it's not true, it displays something that gets you ready. Yeah, so I click the button, and it dynamically updates to ready. More often, it's useful to rely on dynamic modules initialization option, especially with synchronous initialization turned off so that the initialization can take as long as it needs to. So here's another dynamic that checks whether the initialization is complete in the dynamic module. And if the initialization is complete, then it says ready. Otherwise, it says, please wait while I'm doing something. So evaluate this. I'll do that once more. Watch the cell bracket. Cell bracket lights up. It's evaluating, and now it's ready. Okay. And this is how you can get really clever with the please wait indicator. Here is the same example, but with a different set of things saying please wait. You can do incremental progress indication here. You could do indeterminate progress indication, as I've done here. And this is exactly what Manipulate's synchronous initialization option uses to display that indeterminate progress indicator when I evaluate this. There's a very rich and useful language for dealing with progress indication and synchronous versus asynchronous evaluations. Follow the link in this bonus section if you want to know more. Okay. Let's see. So one of the techniques that came in very handy when building out interval slider was the ability to have an internal dynamic module variable and a corresponding external user space variable, and have those two variables always change one another. Whenever one of them was changed, it would automatically change the other one. And one of those directions is easy. If you have your interface and you want to push out updates to the user space, we've built dynamic second argument to do just, well, it does a lot of things. It's nice and flexible, but it can do just that. It can evaluate anything, including setting the user's external variable. So here we have some external variable that sets a value between 0.5 and 1. Here we have an inner variable whose value is the reciprocal. And whenever I change this inner slider, it's going to change not only the inner version, but the outer version as well. So we get one of these directions. We get the value pushing out. But we don't get the value pushing back in. Nothing in the user space is going to push back into the local dynamic module box space. And you can't expect the user to push back into the dynamic module space. In fact, that variable doesn't even exist yet, so the user can't possibly know what variable to push on. So the fix for this has to be in the interface. And the fix that I tend to use in this case is to add a dynamic wrapper around some key part of the interface whose purpose is only to track that external variable and import its value back in. So dynamic wrapper is a thing whose first argument is displayed on screen and whose second argument is tracked dynamically. So here we have a thing that's tracked dynamically whose only purpose is to get that outside variable and import it back into the value of your inside dynamic module. So here, again, it pushes the value out, but now if we change that outer slider, we see that it does successfully push its value back into that interface. So this is a rather useful technique. Yes?
So that means that these two things were executed in a particular order?
What means?
The thing that it's wrapping versus that assignment is occurring for the initiation of the...
The first argument to dynamic wrapper is evaluated when, at the instant the dynamic wrapper is evaluated. The second argument is handled exactly as if it were wrapped in a dynamic. It's just sitting there waiting to be updated like a dynamic would. And those of, if there are people here who are, I mean, dynamic wrapper it's a bit of syntactic sugar, but it's useful sugar. And I'd encourage you to take a look at the documentation for it. Okay. I had planned to stop here. The rest of my slides are bonus slides. If people want to see more, I'm happy to show more. If people want to ask questions, I'm happy to try to answer them.
Can I ask you a question again? In the last slide, if you had executed that last IM36 before you had ever executed IM34, would it still have worked?
Well, let's find out. I'm still not sure I fully grok the question, but let's quit the kernel and start with this guy. Okay, so what does work mean?
I just connect bidirectionally, what you just did.
So yes, I mean, once both are evaluated on screen, the connection isn't somehow mysterious. It's going through the value of this variable. And in this case, out1 is listening for the value of a particular variable, and out2 is setting the value of a particular variable, and they're the same variable. And that's how the dynamic updating system works. Okay. Other questions?
If your utility function, like in one of your second set, when you were using dynamic on the variable instead of placing hold all on the function name.
Yes?
If you need to use so that pattern that you're using doesn't allow for the additional, like, start, run, and end functions. How do you use that and still and access, like if you need to pass that?
If you need to pass additional symbols through to the utility function, then it'll...
Function list that you can pass as the second argument. And then do you have to evaluate them yourself, or like how does that work?
I'm not sure I understand the question.
So right there you have dynamic underscore A, right? So say
Here?
Right.
Yep.
So you could put a list of functions in as your second, pure functions in as your second argument, or like your start, your
You're talking about here?
yes.
Yep.
So then do you have to then run those yourself?
You could, or you could pass them, I mean, okay, I understand the question. So the question is how to support two-argument dynamics in your own interfaces. When you pass them through, what do you do with the second argument? And sometimes it depends on what you're doing. In this case, I'm passing them through to another control, and that control knows how to, let's do it this way. So two-argument dynamics inside of slider know how to handle the second argument already. So in this case, there's nothing additional for me to do. But there certainly are cases, and I think interval slider was one of them, where you do have to build out support specifically for, and not just for the list of three functions case, right? Because there's there's a function case, there's a list of one function, list of two functions, list of three functions. Some of those can be none, some of them can be automatic. It's not drop dead trivial to do, but yes, you'd have to do the heavy lifting yourself in that case. Okay, well, thanks. I'll be here for the rest of the week, and I'll stick around up here if people have additional questions.